Hello everyone, welcome to the NPTEL online certification course on fundamentals of food process engineering. We will continue today with size reduction and we are at the last stage of this particular chapter. We have started discussing on different equipment which are being used for size reduction operation in industry and also in the small scale or lab scale work. So, in that we have discussed the crushers, grinders and ultrafine grinders and cutting and slicing machines, all this we will discuss today. Also we will discuss the homogenizers which is used for the liquid food, size reduction of the liquid foods. So, first is in the last class we have discussed up to the ball mill, and today we will discuss the attrition mill, or that is also called the plate mill or bar mill. So, this looks like the figures are like this. It may be horizontal, may be vertical, surfaces may be flat or conical or vertical and horizontal. That consists of two roughened plates, one is stationary and the other is rotating with a speed of 350 to 700 rpm. So, in this particular case, for example, if you look into this vertical attrition mill, so the inner one is rotating and the outer one is fixed, but they have a corrugated surface throughout for better effect on the size reduction. So, in double runner disc type attrition mill, both discs are rotated. So, the second option is also available. That means, initially we have mentioned that there may be one is stationary and one is rotating, that the picture here depicts that one, but there are double runner disc also where both the discs are rotated at 1200 to 7000 rpm in opposite direction. Size reduction by crushing and shear and the fineness of grinding is controlled by type and plates and also the adjusting gap between these two plates. So, what happened that when we give the feed between these two based on the type and pattern or size of the feed material, we can adjust the gap between these two plates, and also we can control the type of the plate for controlling the fineness of the grinding. So, the capacity of this attrition mill generally varies from 0.5 to 8 ton per hour. So, we can see very small to very large scale, that means home scale to large industrial scale production can be done using attrition mills, and the particle that we produce that generally have less than 200 mesh size, and the power requirement is 8 to 80 kilowatt hour per ton. So, here we can see that every arrangement is a different kind of. In this particular that has been given here, the fixed grinding plate is this one and the rotating grinding is this one, which is attached to a shaft. Okay. The gap of these two can be adjusted and there is a machine casing. So, product will be discharged from the bottom section and the feed is coming from the top. So, feed is coming from here, then from it is going through this top section, and then there is a screw, threaded screw are there, which is taking forward the feed to the gap between these two plates. Okay. So, this is how if we see the products is in between these spaces, there is a corrugated plates in between these, the products is there, and because of the rotational motion the attrition mill works. Now, the advantage is that this is lower in initial cost. If you want to set up a attrition mill, we can do it with very low cost, and power requirement is also less. We are getting the uniform product size. So, that is an advantage. However, there are certain limitations as well. that the foreign material, if they may come with the product, they can damage the disc surface and operation without the feed result in the bar wear because of these issues. So, we need to be careful that only the pure product or the grain that we want to handle should come in between the two plates. Now, agitator mill. So, agitator mill, the grinding medium is suspended in a vertical vessel of 4 to 1200 liter in capacity, which is filled with liquid. Grinding medium is here balls, pellets or sand grains, and a concentrated feed slurry is admitted from the top, and the product with some liquid is discharged through the screen at the bottom. Product size varies from 1 micrometer or finer. Cutting machine. So, cutting and chopping are again size reduction operation based on shearing through the use of sharp edged moving elements like knives or blades. The term cutting is usually reserved for operation resulting in particle with fairly regular geometry forms like cubes and slices. So, rotary knife cutter is an example which we use for cutting the vegetables and all, and chopping it is a random cutting. So, sizing will not be uniform in that case. So, here is a cube cutter which have a specific serrated geometry for the cutting blade. So, it will cut at a particular shape of a cubic shape of all the products, and that is we can see here. And in case of chopping, we just put the abrupt force on the material, so that the irregular shaped particle may come out. Rotary knife cutter, there is a rotary knife cutter which is the knives are attached with all the 5 different cones of the rotor, okay. And so this knives are fixed with the screw, fixed with the arrangement, and there is a screen also. So, when the particle will be reduced in the size because of the action of this blades, they will come down and discharge from the bottom. So, how they work? There is a horizontal rotor in cylindrical chamber, and which rotates 200 to 900 rpm speed. 2 to 12 flying knives with sharp edge are passing with a clearance over 1 to 7 stationary knives. So, here the stationary knives are there. Okay. So, stationary knives, and when the flying knives are coming in between these two contact points, so then the shearing happens and the particle will break. So, feed reduces several hundred times because of this arrangement. Bottom screen opening is 5 to 8 mm. So, when the particle size comes lower than that, it will come down from that sieve. Knives at an angle or parallel to the stationary sieve. So, these knives which are coming down every time. So, there is a 2 stationary knives here, and all the flying knives are attached with the rotor. So, these are coming with an angle or with just parallel to the stationary knives. So, that the clearance between these two should be very less, the stationary knives and the flying knives, so that the cutting action will be done. Now, coming to the size reduction of liquid foods. So, as we have seen that for the solid material, there are very different applications, very different kind of equipments are available which work on the compression, shear, impact, cutting force, etc. Now, if we look into the liquid product, so there also in some application we need to make the smaller particle. For example, the most common one is the milk. When we want to homogenize the milk, the distribution of fat in the milk we want to make uniform. So, we try to reduce the fat particle, fat globule into the small size, and distribution will be uniform because of that. So, those kind of operation we will see now. in that generally we do emulsification and homogenization. So, emulsification is the formation of a stable emulsion by the intimate mixing of two or more immiscible liquid. Okay. So, emulsion we call it because there is a continuous phase and there is a dispersed phase. So, it forms an intimate mixture of two or more immiscible liquid, then we call it emulsion. And what is homogenization? Homogenization is the reduction in size of solid or liquid particle in the dispersed phase by the application of intense shearing force. So, the equipment we use for this application is high speed mixers, pressure homogenizer and colloid mill, ultrasonic homogenizer. So, we will see that one by one how they perform, and also we will see a few detail of the emulsification and homogenization process. So, size reduction of liquid food. In that emulsification, when we want to perform, we can prepare two kind of emulsion, liquid emulsion. One is oil in water, okay. One is oil in water emulsion, that is milk, and water in oil emulsion, that is margarine. Okay. So, more complex emulsions are found in such products such as ice cream, sausage meat and cakes, because oil in water emulsion in milk or water in oil emulsion in margarine, these are most common. And when we go for the ice cream preparation or cake preparation or sausage meat preparation, that time the formation of emulsion, the formation of liquid emulsion structure will be more complicated. Now, there can be naturally occurring or synthetic emulsifying agents that we commonly use. So, naturally occurring emulsifying agents that are protein and phospholipids that we use in the processing. In the synthetic agents in the food are ester of glycerol or sorbitol esters of fatty acid. Okay. So, synthetic emulsifying agents may be polar and non-polar type. Those that contain mostly polar group bind to water and therefore produces oil in water emulsion, and non-polar emulsifying agents, these are adsorbed to the oil to produce the water in oil emulsion. So, we have seen that where the importance of polar and non-polar emulsifier occurs. Now, if we look into homogenization, the action of homogenization reduces the size of the droplets from 0.5 to 30 micrometer in the dispersed phase and emulsifying agent that are present in. Okay. So, they degrade the size of both of them, or it has been artificially added also to the food, the emulsifying agent. So, this reduces the interfacial tension because size has been reduced from very low size from the initial size fraction. So, because of this lot many energy is required, and this reduces the interfacial tension between the phases, okay, and prevent the droplets from coalescing. So, phases, because the phase difference between the the bubbles, the bubbles and the continuous phase, continuous liquid will be there. So, interfacial tension between these bubbles and the liquid phase will be lowered, and that prevent the drops to coalesce once again and form the higher particles. The higher the interfacial tension between the continuous and disperse phases, the more difficult it is to form and maintain the stable emulsion. So, somehow we need to lower the interfacial tension. Emulsifying agents therefore lower the energy input needed to form an emulsion. So, this emulsion and dispersion, you might have done some experiment in the lab where you have seen that to make an emulsion we need to give very high, very intensive energy input, so that we can create the we can reduce the interfacial tension between the droplets and the continuous medium. Now, emulsions, these are characterized by their hydrophile and lipophile balance, that is called the HLB value. Hydrophile and lipophile balance, by which they can adhere to the water or the lipids or the polar and non-polar material. So, these agents that the emulsifying agents that we use, they may have low HLB value or high HLB value. So, these agents with the low hydrophile and lipophile balance value, when it is less than 9, are lipophilic and used for water in oil emulsion. Okay. Water in oil emulsion, just for example, butter or margarine, and those with the HLB values between 8 and 11 are intermediate characteristics and used as weighting agents, and those with a higher value, that is 11 to 20, these are hydrophile and used for the oil and water emulsion. So, we have 3 distinct cases when HLV is very lower than 9, then this agents, which emulsifying agents will use for making the water in oil emulsion. When this HLB ranges from 8 to 11, then intermediate, that means these emulsifying agents are used for increasing the wettability, and when this is increasing 11 to 20, this HLV value, then the hydrophilic nature is increasing and oil in water emulsion will be there. Okay. Now, polar emulsifying agents may be also ionic and non-ionic types. Ionic type have different surface activities over the different pH range, owing to the difference in their dissociation behavior. However, the activity of non-ionic emulsifier is independent of the range of pH. We need to carefully select this emulsifying agent and is therefore needed to create the required emulsion in a given food system. So, choice of emulsion is based on the type of the product, and that is very important. Now, selected emulsifying agents used in the food processing has been given in this diagram, even in this table. So, in the left side emulsifiers list has been given, HLB value is given at the middle and the functions and typical applications are given at the right. So, 1 or 2 we can see, for example, in the ionic emulsifier phospholipid is there, as for example, lecithin, and this is used for crumb softening of the baked products, and that is also potassium or sodium salt of oleic acid. These are used to aid to extrusion and reduction in the stickiness of pasta, snack food, chewing gum, etc. Similarly, if we look into the non-ionic emulsifier, so there are also glycerol monostearate that we are using, and this is using for anti-stelling effect, crumb softening for the baked product. So, we can see that both ionic and non-ionic emulsifiers exist for this baked product softening, and there are hydrocolloids also like alginate, carboxymethyl cellulose, carrageenan, etc. So, based on what is our application, we can select different kind of this material. For example, the bloom retardation in the chocolate, we have seen the fat bloom, that is the fat crystallization may happen on the surface of the chocolate sometime. So, that can be controlled by propylene glycol fatty acid ester, okay, or sorbitol ester of fatty acid. So, using this we can reduce the fat bloom on the chocolate surface. Now, size reduction, when we want to see on the liquids using the emulsification or homogenization behavior, the factor that influence the stability of the emulsion, that is very important, and that can be related using the Stokes law, which says that the terminal velocity V will be d square into g into rho p minus rho l by 18 mu. This is nothing but the expression of terminal velocity. Here the velocity is the separation, velocity of the separation of the phases. Okay. D is the diameter of the droplet in the dispersed phase, g is the acceleration due to gravity, value is 9.81 meter per second square, rho is the density kg per meter cube of the dispersed phase, and if we say rho p and rho l is the density of the continuous phase or the liquid. So, here ideally we should write rho l and rho p, and mu is the viscosity, mu is the viscosity of the continuous phase. Now, the equation indicates the stable emulsion are formed when the droplet size are small, in practice between 1 to 10 micrometer. So, this will be 1 micrometer to 10 micrometer, and the density of the two phases are reasonably close, and the viscosity of the continuous phase should be high. Now, there are different kind of equipment used for liquid homogenization and liquid droplet size reduction, emulsification. So, one is high speed mixture. High speed mixtures used turbines or propeller to premix the emulsion of low viscous liquids, and pressure homogenizer. Pressure homogenizer actually works on the principle of turbulence and cavitation. This is how the pressure homogenizers look like. The feed is coming from one side, and there is a valve, and homogenized product which is coming from this inner gap between these two. These two are called the impact ring, and there is a valve sheet also. So, continuously this valve is pressing on the valve sheet, and the fat globules are disrupted, and small particles will form, and that will eventually mix with the continuous phase. So, what happened exactly, that we will see. The collapse of this air bubbles, which is called the cavitation, and impact forces created in some valve by placing a hard surface. Hard surface is the valve sheet here. So, this process is being done in homogenization of the milk. So, high pressure pump that we use here has the pressure of 10,000 to 70,000 into 10 to the power 3 Pascal. Homogenizing valve which is fitted on the discharge side. So, we have just now seen that this is the discharge side from where the product is the disrupted particle, smaller particle is coming out. So, in the discharge end the valve is there. Liquid is pumped through the small adjustable gap, that is up to 300 micrometer between the valve and the valve sheet, and the high pressure produces a high liquid velocity, that is 80 to 150 meter per second. Then an almost instantaneous drop will be there. Initially the liquid velocity is very high because of the pressure. Now instantaneously those velocity is released because the velocity is drops as the liquid emerges from the valve and mix with the in the continuous section. So, this extreme condition of turbulence produces powerful shearing forces and the droplets in the dispersed phase become disrupted. So, the collapse of the air bubble, which is called the cavitation, and impact forces created in same valve by placing a hard surface or a breaker ring sometime in the path of the liquid, we can further reduce the size of the globule. So, this is how, because of the turbulence and cavitation, the size of the globule is reduced because of the pressure homogenizer action. In milk products, there may be inadequate distribution of emulsifying agent over the newly formed surfaces, which causes the fat globules to clump together. So, therefore, a second similar valve is used to break up those cluster of the globules. So, pressure homogenizers are widely used before pasteurization and ultra high temperature sterilization of milk, and in the production of the salad cream, ice cream and some soup and sauces. So, because of the efficiency of pressure homogenizers to handle the viscous or semi viscous liquid and to make the emulsification better, the ice cream production and also the salad cream production, soup and sauces production use this pressure homogenizer technology. Now, the next is colloid mill. Colloid mills are essentially disc mill with a small clearance 0.05 to 1.3 mm between a stationary disc and a vertical disc rotating at 3000 to 15,000 rpm, and these are used for fine grinding, puree, food paste and pulp, and are processed by this colloid mill. More effective than the pressure homogenizer for the high viscous fluids, high viscous liquid. However, for the low viscous, this colloid mill is not suitable, they will form the clump or aggregation. For example, if for the high viscous product like peanut butter, meat or fish paste, this colloid mill is used. So, the disc may be mounted horizontally as in the paste mill. The greater friction created in viscous food may require this mill to be cooled by recirculating. So, recirculation we can have by chill water. So, to cool the cool the system. So, here the feed is entering from one section, and this is the disc which is rotating, and here from the very fine gap it is coming out the other side. This one is the rotor and this is called the casing. Next we have ultrasonic homogenizer. Ultrasonic homogenizer use high frequency sound wave ranging from 18 to 30 kilohertz to cause alternate cycles of compression and tension in low viscous liquid, and cavitation of air bubble occurs. So, this is how it looks like. The feed is entering from one side, there is an orifice which release very fine amount of the particle through this, and there is a blade which is giving a cutting action to this. There is a crystal sensor and the product outlet. So, sound waves are created which cause the alternate cycles of the compression and tension in low viscous fluid, and cavitation also occur. This is used for production of salad cream, ice cream, synthetic cream, baby food and essential oil emulsions. Now, all this emulsion and the homogenization that we do, they have certain effect on the quality of the food that we produce. So, size reduction is used in processing and control the textural or rheological properties of the food to improve the efficiency of mixing and heat transfer. So, that is because if this is true for solid particle size reduction and also for the size reduction of the liquid material. So, when we increase the surface area, so obviously the transfer process those can occur across the surface area will enhance, that is one thing. Also the similar type of particle, similar size and similar shape of the particle, similar characteristics of the particle will have better flow behavior both for the dry floor material and for the wet material. So, if we look into the effect of this size reduction on the viscosity or texture, especially if we consider a particular food where we practice homogenization such as milk. So, homogenization reduces the average size of the fat globules from 4 micrometer to less than 1 micrometer, and thereby giving the milk a creamier texture. And color, aroma and nutrition value, if we see, homogenization has an effect on the color of some foods, for example, milk. Now, if we see how it is affecting, homogenization has an effect on the color of the milk because larger number of the fat globules cause a greater amount of reflectance and scattering of the light. So, this scattering of the light from all the fat globules uniformly change the color of the milk. Now, flavor and aroma are improved in many emulsified foods because volatile components are dispersed throughout and the food hence have greater contact with taste bud when they are eaten. So, flavors are improved in certain cases. The nutritional value of emulsified food is changed if components are separated. For example, butter making, if we separate the components, the lighter and heavier components, when we separate, then the nutritional value will be definitely going to be affected, and there is improved digestibility of fats and protein owing to the reduction in particle size. So, when particle size reduce, the digestibility of the fat and protein will also improve. Now, also on the nutritional value, we can see that the food is based on different formulation. Okay. So, the composition is an important thing, and based on the formulation used, it is not directly affected by the emulsification or homogenization, it is affected as the composition changes. However, the additional unit operation what we perform sometime after this size reduction thing, for example, chilling, freezing, chilling of the milk or freezing phenomena, baking of the flour, etc. So, they are necessary to extend the shelf life and may cause changes to the nutritional value. Now, in all food emulsion, degradative changes, that means the hydrolytic rancidity or oxidation of the pigments, aroma compounds and vitamins, microbial growth on the finely dispersed material, these are minimized by careful control over the processing, packaging and storage condition, because all of these cases chances of this reaction, the degenerative reaction will be high if we do not maintain the proper storage or proper environment condition or do not follow the proper processing. In many countries, special regulations are there to control the hygienic standard during the preparation of food emulsion, particularly in meat and dairy emulsion, owing to the risk of dispersing pathogenic bacteria throughout the food. Because when we perform this kind of operation, if any contamination was there from prior of collecting the sample, so then it will have a tendency to spread out. So, that is why we need to be very careful. So, here we will stop. The size reduction chapter is over by now. So, we will move on to next topic in the next class. Thank you.